Hi everyone, Mr. Markwick here. Today's video is going to be looking at measuring correlation, and in particular looking at Pearson's correlation coefficient, talking a little bit about what it is and how to calculate it using the graphics calculator. Essentially, Pearson's correlation coefficient, or R, is a value that ranges from -1 to +1. The closer it is to +1, the stronger that positive correlation is. The closer it is to -1, the stronger that negative correlation is between those two variables. And if it's 0, we say there's no correlation. In my previous video, we're looking at the association between numerical variables. And we're kind of just looking at scatter plots, lines of best fits over those points, and trying to make an interpretation whether the correlation between those variables was strong, moderate, weak, etc. But that comes down to individual interpretation. So to make that a little bit less subjective, today we're going to be looking at this table, and when we determine our value of R, it will fall into one of these ranges, and we'll say there's either a perfect positive correlation, a very strong positive correlation if R falls between 0.95 and 1, etc. Okay, so we'll use that to talk about how strong or weak the correlation is between those two variables. Now, there is a formula that is used to determine Pearson's correlation coefficient, or R. For the sake of the Year 12 General Math course, we won't be using that formula. I'll be showing you how to do that on the graphics calculator. There is a bit of a how-to right here. I'm going to use a very similar process, but I'm going to be drawing the scatter plot and then drawing the line of best fit and determining that value of R all in one sort of process, rather than just using the list to find out R. Anyway, let's look at an example first. So this one here, example 2, the Department of Road Safety wants to know if there is an association or correlation between average speeds in the metropolitan area and the age of drivers. So they commission a device to be fitted in cars of drivers of different ages, obviously to work out the average speed. The results are shown here on the scatter plot, and the R value for this association is positive 0.027. So it's really close to 0. It says to describe the association. So 0.027 falls, if you look at this table, it sort of falls in this range here, which suggests that there is a very weak positive correlation. Very, very weak, because it's very close to 0. Okay, so the answer to that would be a very weak positive correlation. Now, in that example, they gave us the value of R, but how do you actually work out that value given a set of data? So here, in the second example, I'm going to show you how to do that. So Botanic Gardens, here example 3, the Botanic Gardens have been trying a new chemical to control the number of beetles infesting their plants. The results of one of their tests are shown in the table. So sample A, they used 2 grams of the chemical and there were still 11 beetles alive. In sample B, they used 5 grams of the chemical and there were still 6 beetles alive, etc. So the quantity of chemical in grams is our explanatory variable or our independent variable. So that's the x-axis, and the number of surviving beetles is our response variable or our dependent variable. So that's our y-axis. So it says here to draw a scatter plot from the data. I'm going to do that on the graphics calculator. So I'll get that up and we'll go through that process now. Just to save a little bit of time, once I head into the stats function, you'll see that I've already put those values into list 1 and list 2. So now I'm going to draw that scatter plot. So press F1 graph. Just make sure that you set the parameters of that graph. So for graph 1, I want a scatter plot. This is usually the default setting, by the way, with my X variables in list 1 as I had X variable, and the Y variables there in list 2, okay, the response or dependent variables. So go back, so exit, draw that graph 1, and that's what the scatter plot will look like. So those points are here, so those 5 points are shown here on the scatter plot. Now, I'm actually going to calculate the correlation coefficient through this graph. So it says next, determine Pearson's correlation coefficient R. So the value of R is equal to, if I press F1 to calculate, X, so F2, and AX plus B, it gives me all these values. I'm interested in looking at the value of R. So as we said, Pearson's correlation coefficient. And in this case, it's equal to approximately minus 0.86. So R is approximately equal to minus 0.86. And then from that, it says to describe the correlation between the quantity of chemicals and the number of surviving lawn beetles. Okay, so find out where this value sits on our table. So minus, so there's obviously a negative correlation here, 0.86. It's very close to the border there of 0.87, minus 0.87, but it's falling in this range here. So there is a moderate negative correlation between the quantity of chemicals and the number of beetles surviving. So for C, the answer is a moderate negative correlation. Okay, which suggests that, yeah, there is obviously some effect on the amount of chemical that you use and the number of beetles that are left surviving. Just quickly, I'm going to show you last little thing here, how to draw that line of best fit as well. So once you're in this section here, the reason I like doing this process is because then I can press F6 to draw that line of best fit through those points, okay? But it really is as simple as that. That's it for the video. Hopefully that explains a little bit about the value of R, or Pearson's correlation coefficient as it's known, and thanks for watching.